Okay, now that we are clear that the Dolphins won their game Sunday, we can go ahead and start talking about the two sections. We're going to do 2.1 and 2.2 together. So right now we're going to start with just a couple of definitions from 2.1. A quadratic function is basically a polynomial function, but this term x squared is the one we're going to be working with. So it's a polynomial function with x squared in it, which, as you know, is a parabola. So the parabola is this U-shaped, and I guess I probably shouldn't put the little tail on there. Let's try that again. This would be a U-shaped, and just make sure in your graphs that you have the arrows, because it does go forever in both directions. So it's a U-shaped graph is what a parabola is. The vertex of a parabola is when you draw that parabola, let's see, you could have one facing up, and your vertex would be here. You could also have one facing down, and your vertex could be here. I think most of this is information you already know. But vertex form, it's very important that you understand vertex form. And it goes like this. We could have a number out in front. We could also have a negative, as we know from our transformations. But the biggest thing is that you're going to have your H inside. So here's what tells me, this 2 right here tells me that it is a parabola. So that I know that's what my graph should look like when I'm done. And vertex form, we're going to learn how to graph today, as well as another form, but where you want to start is with the vertex. And so you get the vertex from the H and the K, which we'll learn on the next screen. All right, so the first thing I want you to do is take, on this page 24 in the workbook, I want you to take the functions that you know, because you know your transformations already, and I want you to match A through F with the graphs. When you're finished, I want you to select over to the next page to get the answers. Okay, now that we've reviewed what the parabolas look like in our shifts and translations, we can now start graphing in what's called vertex form. So I showed you earlier what that looks like, and basically we're going to start with the vertex. So the first thing you have to do is pull out the vertex. Well, how do I do that? Well, look over here to the right, and I'm just going to take any parabola. So we'll just take this parabola right here, I guess. And the vertex is here. Well, if I were to have a left, let's say it moves left 3 and down, I don't know, however much. So this same parabola is going to move left 3 and let's say down 4. And then all of a sudden it lands here. So if I redraw that, it's the same exact parabola, but the vertex moves. So all I really need is the left and right and the up and down direction of the graph to know where the vertex is. So let's go over here to example 1. I have, this one is obviously, if you know your transformations, it's going to move left 2, and it's going to move down 1. And think about it's from 0, 0. So if I move left 2 and down 1, that's going to have me here. Right? So my vertex is -2 for the left part, -2, -1, which is the down part. Okay, so you're just getting it from your left, right, up and down translation. Now we want to pick at least one point on one side. We know that this has an axis of symmetry, so we're going to choose one point on either side of -2. So I could choose -3. I could choose -1. I could also choose 0. But I do have to have at least one of them. So what I'm going to do is choose -1. And I'm actually going to solve this for -1. All right, so that would be -1 plus 2 squared minus 1. In order of operations would give me 1 minus 1, which is 0. So, and I don't have to do a whole XY chart like we did before. I'm just going to plot the point -1, 0. And I know that because this is a parabola, the axis of symmetry tells me that it's going to be the exact same thing on the opposite side. So all I need to have is my vertex, choose one point, and do the axis of symmetry to the other side to get that graph. So you're looking at something like this. Now when you're graphing tomorrow in class, it is going to ask you to give the axis of symmetry. The axis of symmetry is a imaginary line that goes down through the center of the vertex or down the center of the parabola, so that if you folded it, it's the same on all sides. So the way we list that, since it's a vertical line, we have to write x equals, and then it's just this line. So let's see, this is at -2. So it's really just the x value of the vertex. Okay. All right, so let's try another one. We'll do this one over here in green. So we're going to start with the vertex. So hopefully you know that's going to be, by now, that's going to be -1 for the left one, and it's going to be +3 for the up 3. So we're going to start at -1, 3, put a point. Now I'm going to use all my clues here. I know that this one should be facing down. So I'm going to go ahead and expect that, but I still have to plug in a point. So I'm going to plug in 0. My choices are 0 or -2. Anything on either side, so here or here, anything on either side of where the vertex is. So if I plug in 0, I'll have negative of 0 plus 1 squared plus 3. That would be, let's see, 2 it looks like. So I'm going to plot the point 0, 2. 0, 2, and it's going to be the same thing on this side. And it makes sense because it shows that it's facing down, which is exactly what I wanted. So I have this happening here. Now for the axis of symmetry, like we said, that's a line that goes through the middle. And that line in this case will be the line x equals -1. Again, it's the x value of the vertex. Okay, I felt like that was going to be pretty easy for you, so I'm actually adding in 2 different types. This one that we're going to learn now is called the standard, and you've already learned vertex form. All right, so the axis of symmetry, like we said, is going to be the line that goes through the graph, whether it's up or down, and you always want to, since it's a vertical line, you want to write that as x equals some number. All right, the standard form equation of a parabola looks a little bit different. It's written as ax squared plus bx plus c. And so what's going to make the difference here is how we solve or how we graph this one. The minimum value works like this. A minimum value means you have an upwards facing parabola, and the very minimum of that would be this point right here, which is the vertex. The value is the y value. So it's saying what's the lowest value on that graph. So that's always going to be your y, the y value of the vertex. And this will make sense once we start graphing them. It'll make a little more sense, hopefully. Now, a maximum value is if you have a downward facing parabola. And in that case, this vertex at the top is going to be the highest value. So you're going to give the y value, again, of the vertex, but in this case, it's called a maximum value. The other one was a minimum value. And then the intercept form, actually, we're going to wait on. We're going to do that one a little bit later, so you can bypass that. All right, so in your notes, a couple of things you need to highlight are this you already know. It can be facing up or facing down depending on if the number in front is positive or negative. Facing up, facing down. All right. The second bullet you'll kind of see as you graph it. We don't really need to memorize that. The third one, though, this right here is extremely important. Not only do you need to use it, you need to memorize it. So the way that you start finding the vertex is this little formula, -b over 2a, and you'll see that in the next slide. All right, so let's try working one. So what we want to do, we still want to have 3 points. I'm going to start with the vertex. In this case, to find the vertex, I have to start with that formula I said, -b over 2a. Now remember, b, this is a, this is b, and this is c. So b in this case is -4, so I'm going to write it in as negative of -4, which would be +4. And that's going to be over 2 times a. In this case, a is 2. So that gives me 4 over 4, which is 1. Now what I've just found is the x value of the vertex. So now I have to take that 1 and plug it back into the equation, the original equation, to find the y value. So that would look like this. And I hope I picked one that's on the graph. Let's see. So this will be 2 minus 4 plus 1 would be -2. All right, perfect. So we have a vertex of 1, -2. 1, -2 will be here. I already know it's going to open up because the 2 in front is positive. But I need to pick one point. Now my favorite, and I'm probably going to ask you this in class tomorrow, but my favorite number for the standard form to use is 0 because it is so easy. If I plug in 0 into this function, I'm going to get 0 minus 0 plus 1. So I don't even write that out. I just say, oh, it's 1. Well, that's easy. So then I'm going to go to 0, 1. So anytime you can, you want to use 0. Oh, I guess I need that in green. 0, 1, and this axis of symmetry tells me it's the exact same thing. So I don't even have to plug in 2. I should get out 1 according to the axis of symmetry. Okay, so we're going to draw that graph in. And that's all I need other than the the axis of symmetry. Axis of symmetry, which sometimes I write like this, is going to be x equals, again, it's the x value of the vertex, which is 1, because you have that vertical line that goes through at x equals 1. All right, for the next example, same thing. We want to start the vertex as -b. In this case, I'm going to call that -6, because that's b, over 2 times -1. 2 times -1 is -2, so that value will be 3. So I'm going to do this kind of sideways. I hope that's okay, but I'm running out of room here. I'm going to do f of 3 is -9. You'll need to go back and look at that if you don't know where it came from. It's basically 3 squared with a negative in front. And then plus, let's see, that's 18 minus 2. So it looks like then that's going to be 9 minus 2 is 7. Oops, so this is going to be the point 3, 7 for the vertex. And of course, I'm running off the graph there. So let's make these 2's. 2, 4, 6, 8, 10. So my y value is going to be doubled. Okay. Now my x-axis I'm going to stay the same. So I'm going to go to 3, and then 7 is going to be about right here. Okay. Now when I was talking earlier about, actually we can still do this, but the next point I might choose then may be 0, because that would be really easy. I would have 0 plus 0 minus 2. So that would be the point 0, -2. So I'm going to go to 0, -2. Now notice though 0 is 3 away from my vertex. So I'm going to have to go 3 in the opposite direction. Now unfortunately this graph that I chose is going to make me go off the graph, but that's okay. I'm just going to guess it. So I went 1, 2, 3 to get to the vertex. I'm going to go 1, 2, 3 should be the exact same point. And then that's going to get me this downward. Hopefully you already knew that it was a downward facing parabola because of the -1 in front.